welcome to Math1141. So this time we'll talk about Algebra, Chapter 3, Question 49. So let's look at this question. For n bigger than 1, let omega 1, omega 2 to omega n be the n distinct nth roots of 1. What's this mean? Which means omega power of n, like any one of these omega power of n will become 1. So let AK be the points on the eigen diagram which represent omega k. So AK is omega k. And P represents any point in Z on the unit circle. So point Z on the unit circle, which means modulus Z equals to 1. And then let PAK denote the distance from P to AK, which means PAK equal to Z to omega k. Because we say PAK denotes the distance from P to AK. So P is Z, AK is omega k. So P to A Z, Z minus omega k. Now, let's look at this question. They ask us to prove that PAK squared equals to Z minus omega k multiplied by Z bar minus omega k bar. So we got PAK here. Now they ask us to find PAK squared. So we just square both sides, which is pretty easy and straightforward, right? Square. So when we talk about modulus square, we can transfer it into another representation, which is Z minus omega k multiplied by Z minus omega k bar. This two is same. Like we say, complex number multiplied by its conjugate will become its modulus square, which is kind of obvious thing to do. Okay, now we just need to break this conjugate down, which becomes Z minus omega k multiplied by Z bar minus omega k bar, which is the first part of the question. Okay, so now let's find out part B. Deduce that segment between k equals to 1 to n, PAK squared equals to twice n. Okay, now we find out PAK squared equals to Z minus Z omega k multiplied by Z bar minus omega k bar. Now we just sum it up. So we can write it as sum PAK squared will be sum of k to 1 to n will be sum k equals to 1 to n Z minus omega k multiplied by Z bar minus omega k. Right? Now, this rule doesn't help, but how about we just expand out, which become Z bar minus Z omega k bar minus omega k Z bar and plus omega k bar. So we say Z bar is in the unit circle. So Z times Z bar will become 1. Right? Now we say omega k bar is also in the unit circle because omega power of n equal to 1. So if it's in a unit circle, so it will be in a unit circle. So what we got is omega k squared, which is 1. So omega k is in a unit circle because omega power of n is 1. And omega is the nth root of 1. Now, we can add these two up. What we got as sigma k to n 2 minus Z omega k bar minus omega k Z bar. Right? Now we can split it up into another form, which is k k to 1 to m2 minus sigma of k equals to 1 to m j omega k bar minus right? Now because j is not relevant to this, so we can pull out the j bar, which become right. So when we sum out from k equal 1 to m2, it's kind of like sum out nth number of 2, which is 2m. Now minus sum up of omega k bar. What's sum of omega k bar? Now we say in the question omega 1, omega 2 to omega m will be nth distinct roots of 1. So we say omega power of m equal 1. So omega m minus 1 equals 0. And omega 1, omega 2 to omega m is root of this equation. So when we try to sum them up, when we try to sum omega 1, omega 2, omega 3 to omega m, which will be negative b minus a, because sum root is negative b minus a. And in this situation, b is 0, so what we got is big fat 0. Okay, now we take conjugate of both sides. What we got? Omega 1 bar plus omega 2 bar plus omega 3 bar plus omega n bar will also be 0 conjugate, which is 0. Now we can go back to this question. J multiplied by segment k equals 1 to omega k bar. So this part, which is omega 1 bar plus omega 2 bar plus blah 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 plus omega n bar, which is 0. And same as here, omega 1 plus omega 2 plus omega 3 plus dot 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 plus omega n, which equals 0. So this part goes to 0, this part goes to 0, so 2 minus 0 minus 0, which is 2. So we proved part B, deduce that sigma n to k equals to 1 to n, pa k squared equals to 2n, which is end of this part. Now, let's look at part 3, or we can say part C. Now, let P represent a point X on the real axis. X is bigger than -1 and smaller than 1. Prove that pi 8k equals to 1 minus x power of n. This schema, what this simple means? So, k to 1 to n pak, which represent as pa1 multiplied by pa2 and pa3, and so on, and then until pan. Okay, so fair enough. Now let's prove this. We say pak will be, we say x, we don't say z, because they say let x be the point. So we say x minus omega k. Right? Now, when we multiply this up, what we're actually doing is x minus omega 1 multiplied by x minus omega 2 multiplied by x minus omega 3 and so on, and x minus omega m. And because it's modulus, so we can just multiply it up, which become x minus omega 1, x minus minus omega 2, and so on, and x minus omega n. Right? So, does this look so familiar with you guys? I think you guys are familiar with this. If we say x power of n equals to 1, and then we say omega 1, omega 2, omega n is the root of x power of n equal 1, which is x power of n minus 1 equals 0. So we can write this as x minus omega 1, x minus omega 2, x minus omega n, right? So we go in reverse way. If we say x minus omega 1 multiplied by x minus omega 2 to x minus omega n, we can write it as x power of n minus 1. Right? If we say omega 1, omega 2, omega 3 is the root of x power of n minus 1. So we can write x minus omega 1, x minus omega 2, and so equals to x power of n minus 1. It's kind of like equivalent things. Now, because in a question, it said x is bigger than negative 1, but smaller than 1. So which means x power of n is less than 1. So x power of n minus 1 will be less than 0. So when we put absolute value in here, so next we need to take out this absolute value. So what it will be negative x power of n minus 1, which is 1 minus x power of n, which is end of this question. We successfully proved this. So yeah, I think this is pretty much it. So thanks for watching. Hope this helped you guys.